So now I think I'm online. Hi, hello everyone, and welcome again to another Saturday live stream. Microbehunter here. Just let me do a little bit of housekeeping first. Um, I need to see if everything is working fine, and I hope it is. Usually there is always a little bit of a delay that we have to account for, usually about a half a minute or so. Let me quickly check this here. Okay, good. I think, okay, here we go. Yeah, great. Yes, okay, here we are. Okay, now I'm now I'm ready to go. Yeah, what you see over here in the background here, yeah, on the side here, that is actually some dust that I just collected a few minutes ago from my bed. I was actually hoping to find a couple of mites crawling around in my bed. So far, I was not successful. Okay, but today's video is more, about a lighting technique called oblique illumination, and I would like to show that to you. You can see that the setup is also a little bit different that I'm now using up here. It's a different microscope that I'm now using. It's not the DIC microscope, but it's a standard bright field microscope, and there's also a filter holder here that I'm able to use here. Yeah, and I just want to show to you what oblique lighting is, and yeah, we're gonna take it from there. And if you're familiar with this format here, then you probably already know that everything is a little bit improvised. So this means not everything is planned out ahead, and usually the way that the live stream goes depends also a little bit on your comments and your feedback and your questions. So usually what I do at the very beginning is I want to say a hello all around the world. For a good evening from England, from the Belgian coast, from England, from Finland, okay, from Hamburg in northern Germany, from Denmark, from Florida, United States, the Netherlands, Rhode Island, United States. Good evening from Upper Austria. Very nice. We're neighbors. From the Philippines. Hello from Connecticut, the United States. From Romania, from the UK. Yeah, okay, and sound and video works. Very nice. Yeah, you probably already have been at one of the live streams where all of a sudden everything was gone and interrupted. In this case, I have to restart everything from New Jersey, the United States, Sheffield, the UK. Okay, looks like the SW380T. That is correct. The microscope. Hi from Poland, from India. Okay, I hope I didn't forget anyone. Okay, so yeah, so from Poland again. So yeah. Okay, I got to be very honest with you. From Italy, I just recently got an email. Wow, thank you very much. Wow, I already received another donation here. Thank you very much. I just received an email the other day, and very nice email, which I have to still respond to. And I was actually thinking about reading it out to you. A very nice email, and basically saying it's one of the nice things about this these live streams and this channel is that it's brings together the whole world in a common interest. Yeah, and I think to a certain extent, I totally agree. All of us share the same hobby. We love to explore the microscopic world together, and I think that's just great. Yeah, it's also one of the things that always motivates me to keep on doing these live streams here. Okay, so if you're new to the format, please feel free to ask questions in the chat. Please always say @Oliver or @Microbehunter, because otherwise it's going to be too difficult for me to find the comments or questions. Yeah, and basically what I want, it's a special request video a little bit because last week somebody requested, can you talk about oblique illumination a little bit? Now, this is not a new topic, and oblique illumination is also not a new concept. It's going back all the way to the beginning of microscopy. I read somewhere that even in the 1800s, when folks started to observe bacteria under the microscope, by the way, very difficult objects to see, they used oblique illumination to increase the contrast, right? And here it's not great, it's fantastic. We've got it's a comment here. So it's not a new technique, and I have already made a couple of videos before, but simply I also keep on experimenting around, and I yeah, basically just also want to reintroduce this topic a little bit to you. Now, what is oblique illumination? Well, oblique illumination, let me do it like this. I'm just going to give you a little bit of a demonstration here. When we look at here under the microscope, I always have to wait a little bit until it starts to appear. What I'm going to do is I'm going to put a filter in here. I'm going to see over here, this is the filter that I use. I've 3D printed it. You don't need a 3D printer, okay? You can use just regular cardboard as well. And yeah, you see when you put this into the filter holder here on the top, you got to watch now here the top, right? And when I put it into the light path, and what we see here is when we start moving it in a little bit like this, then we actually see that the dust that we see over here looks a little bit like light is shining from the side, right? And this casts a shadow, and this gives it somewhat of a three-dimensional impression, right? I just want to show you this here. This here is what you see over here. This would be dark field. You see that essentially the dust and the dirt and whatever collected here appears to be bright on a dark background, right? You see those blue fibers here? That's usually some synthetic fibers, right? But when I change when I kind of swing out the filter a little bit and I change the position, then sometimes you can get the impression that it does appear a little bit, like a three-dimensional, Let me focus here a little bit. Light starts to come from one side, and this actually increases the contrast a little bit. And when you play around like this, you can get some very nice and some very nice images. I'm going to show you a couple of other nice ones as well. And I would like to simply in this video encourage you to experiment around with it. And I would like to share you some of the filters that I tried, and I would like to simply share with you my experiences. That's pretty much it, right? Ultimately, it's there's a lot of trial and error going on here. Yeah. So, and what I'm going to do is I'm going to start with a little bit of a theoretical background, and I'm going to very quickly move to the desk view because I would like to show you a little bit what I got here and why these filters look more like Reinberg filters and dark field filters and not like the traditional oblique illumination filters. Okay, also this is but let's start at the very beginning. What I got here is this is a condenser from an old Olympus microscope, and I just took it because I had it here, right? And down here what we have is a so-called a push-on or pop-on filter. You see it's a blue filter, and the reason why it's blue is actually because the microscope was a microscope with halogen light. And halogen contains a significantly more red component, and the blue filter gives it somewhat of more of a neutral color. That's the reason why, and also a cooler color, so it also filters away a little bit somewhat of the heat radiation. And this is a pop-on filter, and you can actually put it on here. And this here is of course the diaphragm. For controlling the numerical aperture, the contrast, and depth of field. Yeah, so that is essentially a filter holder. However, this filter holder has a little disadvantage for our purposes because it's a push-on filter holder. And the one that I have right now next on my table is actually a swing-out filter holder. So the one that I'm going to be using today. The filter holder, it's connected with a tiny screw, and then it's able to rotate out. And that's actually what we want because we have a little bit more control. Yeah. So if you have a microscope that looks like this, what you need is you need to put in a filter that here the size is not correct because I won't be using this, but you need to put in a filter which essentially blocks out the light on the majority of the area here and only allows light to pass on an edge, right? And then you get oblique illumination. Basically, it's a light hitting the specimen from the side, and this kind of gives it a more three-dimensional appearance. And because I don't need that because I've got a swing out filter holder, and this allows me a little bit more control. And because by swinging it out a little bit, I'm able to kind of adjust the light more precisely. This is actually a very delicate thing. So if the size is not quite correct, then you already lose the effect a little bit. Yeah. So this is Yeah, there's a comment also. There are also sets of filters available on eBay. Yes, definitely. Just make sure if you buy filters, what you have to make sure is that you get the correct diameter, right? And the reason why I 3D printed those is actually because I've been experimenting around with different diameters and different thicknesses and so on. Yeah, so that's actually the reason. So what you see over here is you see different different colors, of course. You see different diameters here. Yeah, so that's basically a so-called dark field filter. And another thing that you don't see is so much is that also the central patch stop, as it's called, I printed with different thickness as well, because the thickness can adjust a little bit the color. Yeah. So, and what I would like to do now is I just want to show you over here a very nice slide containing radiolarians, because this gives a very strong effect and how this actually looks like. Okay. So I'm going to be changing the slide. I'll be using this slide here. These are radiolarians. These are basically, yeah, they contain a shell made of silica. They're pretty nice looking. And that's a little bit always my go-to specimen if I want to demonstrate dark field or oblique illumination or Reinberg illumination, because they kind of look very nice. Okay. Oh yeah, I have to, of course, switch over to the different view again. Yeah, it takes a little bit of time for the camera to, yeah. And what I'm going to do now is I'm going to try to find. So these are basically, it's not what I have right now. This is a regular bright field. I'm going to close the condenser, and those radiolarians, they really look pretty. Yeah. So, and I'm probably also going to go up with, yeah, these are very nice looking specimens. And just turn up the light a little bit, and this is how they look like. Yeah. So these are marine, yeah, basically from the ocean, and then they have those nice shells made of silica. Okay, let's go up a little bit with the magnification here. I have to readjust everything. Yeah, and this is now basically a regular bright field. I'll be using mostly this. It's the Swift 380T. Yeah, and they look pretty. I really like those. Okay. And yeah, and what I'm going to do now is the following: is I'm going to show you how they look like with this. Where's this? Yeah, with this filter here. Okay, so that's the one I'll be using. Yeah, and let's have a look. Yeah, and because this is just a regular dark field filter, and let's put this in here. Yeah, and I have to open the condenser completely. I'm able to find it, and then I put it in here, and this is how it looks like. And unfortunately, it's a little bit. I need to reduce the light here. It looks a little bit overexposed because of the camera. But in dark field, but maybe that's also one of the disadvantages that we see right now. Dark field gives you a very strong contrast. Yeah. So right now this is a little bit of a camera problem. Yeah. So the difference between radiolarians and diatoms is, both of them are single-celled. Radiolarians are amoebae, and diatoms are more related to the algae. Yeah, they're photosynthetic, but in the sense, but they both have shells made of silica. Yeah. So and yeah. So what we have over here is now basically a slightly how do you say overexposed. Yeah. Overexposed example, and that's already one of the disadvantages. But now look what happens if I now swing out the filter a little bit. Okay, I'm going to do this. I'm going to swing out the filter a little bit. Okay, and then what you now see is now you see actually, and now you can adjust this a little bit. You can now see, yeah, as I move it back and forth, you can now see that. The light appears to come from one side, and you get almost this three-dimensional impression, yeah, which looks quite nice. For example, you know what? I'm gonna turn on the arrow here, simply to point. Yeah, you now see that over here there is a dark edge over here, right? And there's a bright edge down here because the light seems to be coming from the side and casting a shadow, and this gives it the impression of having some kind of a feeling of depth. Yeah, and that's essentially one of the typical characteristics of oblique illumination. And just to show you again, I'm going to now remove the filter completely, right? And this is basically how it looks like without the filter, right? It looks much more flat, yeah. But with if you just move the filter in just correctly, yeah, it's too much, yeah. And you can actually see that, yeah, it looks much nicer. Yeah. So this is a little bit. The effect is somewhat similar to so-called DIC, differential interference contrast. The mechanism is quite different, but it's similar to that, and it basically, with one huge difference that you're getting a similar result with practically no cost, no additional cost. Yeah, because DIC is horribly expensive because the optics are so expensive, but oblique illumination like we're doing here is really cheap. Yeah, you just need the filter. Yeah. Yeah, here as well. And the interesting thing is that oblique illumination actually works also quite well. Now I lost the focus a little bit. Also works quite well with at a somewhat a lower at a lower magnification, at a higher magnification as well. So let me see if I'm able to manage to find this, because if I that's maybe I have to find it. It's probably a little bit off center. Here we go, and out of focus. Here we go. Yeah, that's now. I'm now at 40 times. You see, it's already a little bit blurry. But let's move the filter in again. Okay, let's move then you can actually, yeah. When you move it back, you can actually see how the light is kind of redirected a little bit. Yeah. Yeah, but yeah, the depth of field is already quite low. Yeah, so but maybe it's easier we just stay with a 10 times magnification here. Okay, this is again a dark field. So that's basically with the best images. Yes, you gotta stack it. Marie is saying it. The best images probably come from stacking. Yeah. So what I want to do now is, however, I want to show you also some another filter here. And what I've been experimenting with, where is this? The desk view here. And that is this one over here, which I printed with a white filament, and I made the central patch stop disc very thin. The question is now why? Because I wanted to reduce the contrast a little bit, because I found that if you completely block out the light, then it's kind of the contrast is very extreme. So I just experimented also with different colors and trying to give it a little bit of a different background color. All of this is possible. And now let's have a look at this one over here. Yeah. You should do with Christiansen illumination. I have to still read into that. I've heard about this, but I'd have to read a little bit more into that to do a video on this. So let's try this one over here, okay? Which I've printed this one here also just today in the afternoon. Okay, it always takes a little bit of time for it to, Let's put it in here. Okay, and the reason why, by the way, the reason why the background is now black is because what we're now it's actually I'm going to use a different one here. It is actually the edge of the filter that's now blocking out the light. That's the reason why it looks like dark field. Okay, it's the edge here that's now in the center of the image, and this causes the specimen to look bright on a dark background. Yeah. Yes, ever smaller just said about Christiansen illumination. Please send me the PDF. I would be very thankful. Okay, and I found it actually that if you use the white filter, you actually have more control over the whole thing. Yeah, so this is actually also something that I would recommend. Is not to completely block out the light, but to try different. So-called color densities here. Yeah? It's also quite nice. Yeah, because the contrast is not quite as sharp, and here we're basically now have again the edge of the filter holder right in the center. Yeah, and now by controlling it we can actually and now the central part is right in the center, so we have to make sure that there's more light from the side coming. So I have to rotate the filter out again a little bit. Yeah. So that's the radiolarians. I'm going to show you also a couple of my own cheek cells, which basically become much better visible using oblique illumination. But I want to show you now the following, because we also have done also played around a little bit with a little bit of some color. And just to show, with limited success, okay? With but just for demonstration of what I also tried, I think it's this one over here, but there is not that's the one, there's not a huge difference. So what I don't know if you're able to see this, but I actually tried to make a thickness gradient. So this side over here is actually thinner in the center. You have to refocus. This one is actually thinner in the center than this one over here. Right, so it's slanted, but I found out that it's generally too thick and it completely blocks out the light. So not everything works, and that's one of the reasons why I've been 3D printing those, because it's easy to create a large number of filters for trial and error. That's the only reason. Okay, but I just want to show you now. I think this one over here seems to. I need to choose a very thin one. I think this one is fairly thin. Yeah, let's try this here, and I just want to show you how this one looks like. Yeah, so this is actually, yeah, and because the blue color in oblique illumination unfortunately does not have a huge effect. Okay, so I'm going to put in this blue filter here, right? And that's so-called again dark field or Reinberg. Again, unfortunately, a little bit to brighten that. The reason why it's so overexposed is because the camera tries to adjust. Yeah, I'm turning down the light now a lot. Yeah, but if you look actually through the microscope eyepieces, then actually it looks quite nice. Yeah, but over here it's because of the limited dynamic range of the camera that the specimen now completely looks washed out. Yeah, okay, yeah. So that is so let's swing it out a little bit again, and yeah, when you swing it out, yeah, and that's a little bit the thing that I discovered. Look, the color doesn't seem to have a huge effect. Yeah, that's a little bit the interesting thing. When you push it in completely, then yeah, it's blue. But if you push it out, the color doesn't seem to have a huge effect here. Yeah, that's a little bit an interesting phenomenon. Yeah. So that's something that I kind of discovered. So the color is good if you just want to do it Reinberg illumination, if you just push it in all the way. But as soon as you go oblique, then yeah, for whatever reason, the color is not evident anymore. Yeah, so, but you know what I could try? I could maybe go up a little bit with the magnification. Okay, that's another thing. Look at the top here. Let me recenter it. Yeah, so that's another thing that I just want to show you. You now see that the background is not dark at all, and that's the reason is because the size of the central disk is not large enough. Yeah? But I want to show you now another thing here, and that is a green one. Okay, so I'm going to exchange it again. Let's go down with the magnification again a little bit. So I'm putting in now a green one. Yeah, and this is how the green one looks like. Yeah, so this one here is the green one. Okay, and again, if you start to move it out a little bit, yeah, the effect of the color isn't there anymore for whatever reason. Yeah, so that's quite an interesting observation. Yeah, but that's also something where we learned something. So that's essentially the how do you call it, the radiolarians. Yeah, and they're pretty nice. Yeah. Now, just for comparison again, I'm just going to take it out now, the filter completely, and I'm going to close the condenser. And of course, you get a larger depth of field. Yeah, but this is how it would look like in with a closed condenser in a regular bright field. Yeah, yeah, and when you put in the filter again, you have to open the condenser, yeah, otherwise it's going to be completely black. Yeah. And the interesting thing a little bit, look, if you move it back and forth, you can actually see, because the angle of the light is changing, yeah, it's almost like if the image itself is shifting. It gives a slightly, I don't know, yeah, yeah, you can actually see also a little bit the depth here, yeah. Yeah, so quite nice. So why am I showing this to you as well? I receive not few emails from people, or not only emails but also comments in the YouTube videos where they buy a microscope and then they immediately say, okay, I want to improve it some, I want to upgrade it, right? And my recommendation is before you invest any money in upgrading the optics, which probably won't make a huge difference anyway, I recommend that you play around a little bit with different types of filters. Yeah. Do you ever look at forams? Okay. Let me check. Let me check. Number four. Number four. Question. What are forams? Here it is. I got a slide. Okay. Okay. Foraminifera. Yeah, because you're asking. These are basically have shells made of calcium carbonate, and they also look quite nice. So I'm going to put those in, but we might have to. Yeah, I'm going to remove this here. We have to now really go down with the magnification again. I have to refocus. Yeah. And question is where are they? Yeah, the thing is that here, yeah. These are not formed, but sometimes they're a little bit dark. But they are also lots of sand grains. But these are also single-celled, the shells of single-celled organisms. But you have to be a little bit more patient here. Sometimes they look a little bit like sometimes like tiny snails. Yeah. Yeah. So maybe this one over here could be one. Yeah. By the way, this is a commercial sample what I have here. Yeah. Or this one over here possibly. Yeah. So you have to, you have to kind of look a little bit. But let's see again if I'm able. Honestly, I have not tried oblique illumination or anything like this with on this sample here. So I don't know if it's a little bit like dark field. I don't know if not all samples are equally suitable. This seems to be a little bit the sample seems to be fairly thick, but occasionally yeah. The effect is not quite strong here. That's a form here as well. Yeah. These are basically also the shells of marine microbes. Yeah. Top light oblique is a question. No, I don't have top light, and generally it won't always work as well because especially at higher magnifications I have problems shining a light from the top because the objective of the microscope actually is blocking the light. Yeah? So that is a little bit the issue. So it's actually a geometric problem that sometimes, especially if you have a top light, then yeah, sometimes it will cast a shadow. Yeah? But you see over here the tiny things that you see over here that looks a little bit like oblique. Yeah. So what I would like to do now is I'm going to take again one of my how do you call this, my cheek cells, because I also tried that, and actually the cheek cells they are one of those examples which actually work fairly well, surprisingly well, because cheek cells not being they don't have much of a color, being very transparent. Actually, as one example where oblique illumination actually works quite well. I read somewhere, I don't know where, I don't know in which book or where, that back in the 1800s, because the microscopes at that time were not that great compared to optics, were not that great as now, they had to, of course, use a lot of staining techniques to make the structures better visible, and also bacteria were difficult to see. But apparently they used oblique illumination and were able to make them visible much better. So it's actually a technique that has been used apparently quite extensively back in the 1800s. Yeah. I'm just reading the comments here. Okay. Okay, I'm just reading some of the comments. So I'm going to try to make now a slide using my cheek cells, okay? That should be enough, okay? So I'm smearing my cheek cells on here. Okay. There's a song contest going on right now. So I was I'm wondering how many people are watching now the song contest and how many are joining the live stream. So I was actually quite happy that at least there are a few people who are joining the live stream. So yeah, I basically smear. You can actually see it over here. Yeah, there's a little bit here. I'm gonna throw this away. A little bit of water I need. So I got some water here. Okay, and a cover glass goes on top. Okay, you don't want to use too much water here. So, and yeah, just, you know what, I'm going to remove a little bit some excess water. And because I want the specimen to be really thin and flat. So I think that's gonna be fine. And let's have a look at this. First in bright field, again, those cheek cells not being stained are actually generally a fairly difficult specimen. And I hope that I've got enough in here now. Stereo view. Not stereo, yeah, here we go. Yeah, I'm just going to use the regular, and I have to refocus. I'm going to always close the condenser. Yeah. What are these black spots? Maybe there was some, weird. Maybe I did not properly clean the slide because I've washed them before and maybe I did not, yeah. What would you usually use them? You can use methylene blue. You can also use crystal violet. But here there are a whole bunch of cells already. Okay, so all of these cells that you see here, okay, these cells here in bright field now are my cheek cells. Yeah. My Swift fails to produce such oblique. Well, you have to, you make sure that the condenser is all the way to the top. Okay, so that's important. If you have a problem, there is a you can rotate this. Look at this here. Okay. Here, if you rotate this part, you're able to raise and lower, okay, the condenser. Just make sure it's all the way to the top. Yeah. So I'm going to now swing in the how do you call it, the filter, and here that's now the frame of the filter. And when we continue doing this, we hopefully that we're able, yeah. So let's see. We have to open. I forgot to open the condenser, and now you actually see that the cells also seem to have this three-dimensional appearance. Yeah. And they start to stand out. Yeah, and that actually is also a way of increasing the contrast. Yeah, and that's one of the nice things here as well. Yeah, if you put in the filter all the way, you won't see anything. Yeah, if you put the filter out all the way, yeah, then the contrast is so low that you also don't see anything. Then you have to close the condenser, right? But then it looks fairly flat. Yeah. So you see there are lots of things that you can experiment around with here, right? Here, this one here is a very strong effect. But look, I'm going to show you something. I'm going to take out the filter completely. Okay, so it's completely removed, and look. with an empty filter holder, when I'm doing, maybe, yeah, you see it's empty, yeah, at the top, yeah. Look, if I rotate the empty filter holder in here, I get dark field, and I also get oblique illumination. Isn't this interesting? Yeah. And the reason is because it's the frame of the filter holder that now acts as the filter. Yeah. So it's kind of funny that, strictly speaking, if you want to play around with that, you don't even need a filter. Yeah, you just can use the edge of the filter holder, yeah, to get a similar effect. Yeah. So if you in other words, if your microscope has this swing out filter holder, you just try to put it in a little bit, and then you get oblique. And if you do it further, something like this, then you even get dark field. Yeah. And again oblique. Yeah. Look, I just want to show you something here. Something quite you have to just watch carefully. I'm going to use the arrow again. Depending if you're using the inside or the outside edge of the filter holder, look at this edge here, right? At the top now, the edge is bright. The top edge is bright. I'm going to leave the arrow there, right? Like light seems to be coming from the top. Up now, I bumped it and bounced it. So let's try it here again. You know, it's easier for me to, yeah? So the top edge is now white. But look, if I change the filter, now the top edge is dark, right? And now the top edge is white. Yeah. So depending on whether you use the inside or the outside of the of the ring of the filter holder, you can actually change the direction of the lighting. So it's really there's so many things to play around with. And however, bottom line is again, not all specimens are equally suitable. I really have to say that. I mean, some specimens really work nicely, and others they don't. They don't. Yeah. So what is a screw mount? I don't know. And is this suitable for long-term storage and repeat? I don't know. I'll have to research this, okay? But thank you for Marcel is saying, what's a screw mount? Maybe if someone of you know that, yeah? I remember how you taught us to put a little piece of cardboard in the light or your hand. I played around along many hours. Yeah, you can, essentially what you can do, just for your info, I've also done that. I don't know, you take some kind of a plastic piece, like I don't have one here right now, like from a plastic bottle or something, and you cut it out, and then you just glue some cardboard in the middle. You can make your own filter. Yeah. So this is simply something that's possible as well. Okay. So that is basically the cheek cells that I have. Okay. Okay, and a sliding filter. Honestly, if you have a sliding filter, that should also work. Okay, if you're able to slide it, I have also a microscope downstairs where basically you put a filter in and you can actually slide it horizontally, but that also kind of displaces it from the center, and it should work equally. Yeah. Lots of the standard filters I see online don't fit since it seems to be proprietary. The thing is the following. I get it, and I probably, you see the point is the filters not only have to fit into the filter holder, but the size of the central patch stop, if you want to use dark field or Reinberg, also has to be the correct size. If you make it too small, then the background will not be completely dark. And if you make it too large, then the whole image will be too dark. And this basically the diameter, optimum diameter also is different on the magnification that you use. Yeah. So, and I found out that this is actually quite sensitive. So if you change it around, if it's just a little bit too small, the central patch stop, then you will not get a properly dark background. Yeah. So that is the thing that I just want to inform you. And therefore, I would sometimes suggest trial and error, and you just you can use some felt tip markers or some cardboard and so on, and glue it on a transparent plastic disc, and then you can essentially play around with that. Yeah. So let me quickly check a little bit the time that we have. Okay. Yeah, 17.5 millimeter. Yes, that's, yeah. So for example, this one over here is 17 millimeters. When it's 3D printed, I even also printed it on here. Yeah. Yeah, so that's the thing. So what I've done is I simply made these filters are printed in just a couple of minutes. So I made a whole series going from, I don't know, 10, 11, 12, 13, 14, 15, 16, 17, and so on. And generally what you do is you want to try the different ones, and then you just throw away those that basically don't give you the results that you want. Yeah. Yeah, the thickness 0.2 millimeters. Generally, if you want to block out the light completely, yeah, then you can just make it a little bit thicker. But what I've done here is if you want to use a background, if you want to give it a background color, then it should be fairly thin. Okay, so I've got 0.2 millimeters. Yeah, so that is the, yeah. Thing here. Yeah, the print labeled one here. Exactly. Yeah, because otherwise it's too. Yeah, I've made a whole series of those and I've thrown them away if they didn't work, because otherwise, yeah. So that's why it's trial and error, really. Yeah. So let me do the following. I have not tried that either. Let me see. So that's again those. Let me see how this actually looks like if I put in the green. I don't know. Yeah. See. Nope. Yeah, now everything's green. Okay. Let me see if when I open it. Ah, you see, nah, it's barely visible. Yeah. The contrast is too low. Yeah. Move it over like this, maybe. Yeah. See, then we're going into oblique, and we're kind of losing the how do you say, the color again. Yeah. I mean, that would be somehow, I don't know how this would. Now we got a little bit greenish color here. It would be really nice somehow to make sure that the background would be green, and I don't know. Yeah, maybe put some green over the lamp. Maybe that does the trick. I'll put some green over the lamp directly. Yeah. Nah. Yeah. So as I just said, it's a question of trial and error, right? So yeah, it's so fun. Yeah, you can spend an afternoon playing around. Yeah. So why I'm saying this, before you think about upgrading a microscope and changing around objectives, you can do that, of course, but why not play around a little bit with those filters here? Yeah. By the way, if you're new to this filter business, I've got in my other channel, which I called Microbehunter Microscopy, which is a little bit more the technical channel where I'm doing also microscope reviews. I made a couple of videos simply about making filters, and also I've been printing some filters also on overhead foil. Yeah, so using a color printer. Yeah, so you can also do that. Yeah. How far with the magnification can you reasonably get with dark field or Reinberg? Okay, honestly, not on 400 times total magnification is stretching it. And the reason is because it's taking away already so much light that it's difficult to see. But let's do the following. Let's go back here. Let's just use this here as an example again. Yeah. Let's go up fully with the light. So that's now maximum light. The camera does adjust a little bit. And let's put in a dark field filter. Okay. And yeah, again, the problem is that's a little bit of a camera problem, right? Where it's completely overblown, right? And now if I go to 40 times, yeah, it's a little bit. I think I've lost it a little bit. Here we go. Yeah. Let me see. Yeah, no. The background is not completely dark either. Yeah. Let me check here. Yeah, here, this one. It's not in the center. Yeah, here we go. Yeah. So that's now using my 40 times objective, right? And yeah, it's still okay. Yeah. But because you have to open the diaphragm completely, For this reason, the depth of field is also going down. Yeah, so this basically means that yeah, it does not look quite as sharp and crisp because some parts are always out of focus. Yeah. So that's the thing a little bit. Yeah. So generally, I recommend. Yeah, and right now this is a 17 millimeter patch stop in the center, right? And if you basically make it too small, then the background is not going to be completely dark, right? So the 10 times over here, yeah, you see, that's a little bit the pity with the 10 times, because the camera thinks now that overall, because of the dark background, it tries to it overexposes. When you look through it, it actually looks very nice. Yeah, it looks very nice when you look through it. You know what? I don't know. I'm gonna. Does this work? Nah, unfortunately, don't. Nah. Nah, this doesn't work. I'm trying to use the camera now to. You see, that's a little bit one of the disadvantages of yeah. That unfortunately we're limited a little bit by the dynamic range of the camera, yeah? Which is a pity. Yeah, and I tried to adjust it. I can show you if I want to adjust the how do you say, the image quality. I can do that, but the problem is, look, if I go down with the brightness, the whole image just becomes darker. Yeah, but I will not see more details. That's a little bit the problem. If I change the contrast, yeah, you see, I'm also not able to change, get more details. That has to do something with the limited dynamic range of the camera, unfortunately. Yeah, yeah, that's a little bit just in the nature of the whole thing here, right? And that's why sometimes also when you shift out the filter and go oblique, then the light is a little bit more balanced out, and you are able to see the details. Yeah. So that's the neutral density. Yeah. I don't know if I make it darker. Generally, this could be. I'd have to probably or maybe go play around with the camera exposure, but the settings, they don't allow me to do that, unfortunately. Yeah. Yeah, okay. So every now and then I'm reading again the comments. That's why I'm pausing a little bit. So what else is there? Let's have a look. Maybe this one over here. Let me see. This is a part of a leg of a bee. If I just you see, that's one of the difficulties, is always trying to find it where it is. Let's remove the. Here it is. Okay, this is it's just a part of the leg of a bee, and yeah, if you now essentially can now see that the background here, and that's also one of the things I wanted to show you, and that's a little bit one of the disadvantages of using dark field, is do you see all of those white spots here? That's all dust. Yeah, so dark field is unfortunately extremely dust sensitive. Yeah, so if there's somewhere a little bit of dust in the light path, then it will look like this. Yeah, we can try to focus. So that's basically on the slide. Yeah, there is now something really interesting that I need to tell you. It's a little bit counterintuitive, but it's really fascinating. Because dark field, like we've got over here, increases the contrast so much. It is, you gotta hear me out here. It is possible to see structures that are below the resolution limit. However, you're not able to see any details, so you're not violating the limits of resolution or physics. But what this basically means is the following, that because it is so sensitive to dust and tiny particles, what you're able to see, for example, here is you see those little dots here, the dust particles. It could be that some of these dust particles that you see here, some of the dots are actually much smaller than they appear, right? But you're still able to see them. So theoretically, it is even possible using dark field to see viruses. Yeah, but you will not be able to see the structure of the virus. You're just going to see some kind of a bright spot, which is actually larger than the virus. Yeah, so that's because of the increased contrast. So that's kind of interesting because you're actually able to see things that are smaller than the resolution limit, but you're still not violating the laws of physics because you're just seeing a larger blob. Yeah, but the actual structure that you see is smaller, right? So it's a little bit like when you go over here and now it's out of focus. Yeah, maybe I'm just going to turn it the other way, something like this. Yeah, then you're actually able to see that there is something here, something must be there, but the actual structure is much smaller, right? And so therefore, apparently, it is possible theoretically to even see viruses using dark field, but you won't know that it's a virus because you're only able to see a bright blob. Yeah, so so that's kind of the interesting thing here, right? Yeah. So this here, by the way, I've also tried this, is an example where sometimes oblique, because it's so thick, does not quite work as well. Just a little bit. If you just shift it out here, yeah. So something like this, yeah. Then you can see that sometimes you are able to see again here this oblique lighting that you see over here, but not so much in the rest of the structure. So I think this tells me a little bit is that if you want to see it quite well, then the structure has to be probably sufficiently thin, yeah, for you to see this oblique lighting effect, which probably explains a little bit why they have used it back in the 19th century also to observe bacteria this way. Yeah. So, yeah. So I'm checking the time. Okay, it's almost 1 hour again. So this is basically something I wanted to show you. What we can try to do, because I try to do this every time, to look at some live specimens. You know what? I've not tried this yet. Honestly, I really did not try it yet. Let's try that. Let's have a look at some of the nematode worms. Yeah. So let's have a look. I'm going to try to check out some nematodes. So this is, you don't see that because I did not. Okay, so again, this is something I didn't try. So let's have a look if those nematode worms actually work well in oblique or dark field or whatever. I need a pipette. Okay. By the way, can I just say something different, a little bit off topic? There has been a request a couple of months ago or so. Some of my viewers wanted to see some videos which are a little bit more biology related, some deep dives a little bit into certain biology topics, and however those topics would not really fit into this channel. Right, so I've got another channel as well, which I opened, I think 5 years ago, but which has not been very active. I call it All Things Microbes. If you want, I can post a link maybe into the chat. Yeah, it's not biology 101 it's not it's more I do talk about certain biology topics, but it's not like school lessons. But if you want to have a look at a couple of videos that I posted in the past, you might want to check out All Things Microbes. I think yeah, I'm gonna post the link now in the chat. Okay, click. Yeah, I just posted the link in the chat, and you might want to check out this channel as well. Yeah, yeah, maybe I've been thinking actually about making more videos. Yeah, so these are quite different in the style. These are a little bit more scripted videos, and it's a little bit more the traditional talking head type of lecture style. Okay, so yeah, just saying it's in the style. It's different than the somewhat the ad hoc videos and the slightly improvised videos that I'm doing on this channel. The other channel is a little bit more, how do you say, structured, I would say. Yeah. So I deliberately try to play around a little bit with the different styles. I don't know if I caught any. I hope really that I've got some of those worms on here. At least one of them. I don't know. What was this? Yeah. So let me quickly check through the microscope here. Do I have any worms? Are there any worms visible or not? Let me see. Yeah, got one. Okay, very good. They're. I used very little water, so it kind of squeezed in a little bit and sandwiched. That's pretty good. So see, that's basically a regular bright field using my 4x objective. So that's one of these nematode worms, a vinegar eel. So I don't know. I have not tried the how do you say? So where's this here? Let's focus. It's blurry. So here we go. I mean, it's even pretty good in the bright field. I mean, honestly, yeah. No complaints here. I'm gonna use the white filter because that has given me one of the strongest oblique effects, and I'm gonna see if this actually works or not. Let's have a look. Let's open it, and let's see if that's dark field. Yeah, actually it works quite well. Okay. Now you actually see that the light is now coming here from the right side. It's bright here, and over here it's dark. Yeah. It looks quite actually quite okay. It's a little bit limited in its movement. That's good because it's kind of sandwiched a little bit between. Yeah. These are so-called vinegar eels. The genus is called Tubatrix, and they are actually sold as fish food if you have an aquarium. And you can breed them quite easily by adding a little bit of vinegar and water and sugar. Yeah. Actually, this is a very nice one. Okay. Yeah, looks the oblique effect, surprisingly slow for a nematode. It is slow because I limited its movement. There's so little liquid that actually it's squeezed between the cover glass and microscope slide. Okay, so that is that's the reason why it's I bumped it. That's why it's so slow, right? It's physically limited in its movement. Yeah. So maybe if I find, I don't know, if I find a smaller one somewhere, yeah, then let's see. This is now using the 4x objective. Even here with the 4x objective, it works surprisingly well. Actually, I'm quite happy with this one here. With this, I have to find now. I don't know. There are not a lot of them that I've got in here right now because the sample seems to be so. I need to check again. It's an air bubble. There's another air bubble. Here's another one. Okay. This one is a little bit smaller. Yeah. It's able to move a little bit more because it's a little bit smaller, right? Yeah. So how do nematodes use vinegar? The vinegar is an acid, a weak one, and yes, still. So the thing is the following: those nematode worms in nature are actually grow on decomposing fruits. So, for example, apples and so on fall from the tree, and what will happen is that they will start to ferment because bacteria and yeast start to convert the sugar in the apple and in the fruits into alcohol. And then bacteria will also convert the alcohol into an acid. And when now flies, for example, land on these decomposing fruits, they will carry along the nematode worms, and the nematode worms actually in nature feed on those decomposing fruits. So they are used to an acidic environment. Yeah. This basically means that if you add vinegar. And you have to dilute the vinegar with water, and you have to add some sugar. Then this imitates a little bit the natural environment that they are able to survive in. Yeah. So this is essentially. Thank you very much. Okay. Your questions, your questions are here, right? Yeah. So let's do the following. Let's move in the. Let's try the following. I'm going to now try the how do you call it, the blue filter again. Where is it? Let's see if how the blue filter works. Yeah, see, that's the blue filter now. Okay. again, under the microscope directly looks much nicer than here on camera. Yeah. But yeah, I guess you get the idea. Let's see, if I shift it out again, then I'm getting again into the oblique illumination. Let's try green. Let's try green. Yeah, green doesn't quite. Yeah, maybe now a little bit. Yeah. Then when I shift it out, then I'm again in this oblique. So let's go up with the magnification again. I need to always refocus. Here we go. Yep. Plenty of things to play around with. Yep. Let's see. Here it is. Yeah. Again, this is a way to limit if you use too much liquid, then they're gonna move so quickly that you're not able to follow them. Yeah. So that's a little bit thing here. So I'm just going to do the following now. Yeah. You know what I'm going to do? I'm just going to demonstrate. I'm going to add a little bit more vinegar now, okay, to the slide, or more liquid, and then maybe it actually should. I'm now adding liquid, and then it should be able to move a little bit more freely because there is now more space. Yeah, see? Yeah, now it's able to move again. Yeah, here we go. Yeah. So all I've done now is added a little bit more liquid, and then see, it's too difficult to chase. Yeah, it's gone. Yeah. So that's the reason why I added very little liquid to make sure that yeah. So what I've done is the following: those vinegar eels, I added regular vinegar, 50% vinegar, 50% water, and a spoonful of table sugar, and that's it. And that I keep on growing it. So I got those vinegar eels from a colleague in work, who basically keeps a home aquarium, and he just gave me a jar a couple of years ago actually, and I've been growing them. I've been growing them ever since. Yeah, I've grown. Yeah, and every time when I want to need more, I take some sample out and retransfer it into a different jar. Yeah, yeah, and you see those tiny dots that are. It's a little bit cloudy, and those tiny things that you see are all basically those worms. Yeah, and so yes. So what I'm gonna do now? What time is it? Okay, I'm going to slowly now read some of your questions. Okay, let me close this here, and let me see. And I really, yeah, before I do that, this is basically what sticky tape, and I collected some dust from my bed, and from the mattress of my bed, with the hope of finding, some dust mites. Yeah, so these, is something that I would really like to find. Have not found them yet, but that's what I'll be looking here. And I'm really see. You know what? It's actually one of. I love this question. Here's a somewhat of a philosophical question. I'm reading out the comments here. Do some of these single-celled organisms, under quotation marks, think? Can they be trained to respond to stimuli in a specific way, like dogs to the sound of a bell, for example, like conditioning? They can, well, generally, one also has to be a little bit careful with terminology, but if you say think, and I know you put it under quotation marks, I would say no, because they don't have a nervous system, right? And simply because they are able to respond to an environmental stimulus does not automatically mean that they're able to think. Yeah. The question is, are you able to train them somehow? Is there some kind of a process of learning happening? What I read somewhere is that there is a very, in some microorganisms, ciliates, or so, I think I read somewhere there might be some form of habituation, as it's called. Basically, that if you keep on stimulating them, that sooner or later they will not respond anymore to the stimulus. So the question is this some kind of a learning, really? It's not really learning either, but it's kind of like a predecessor to learning. So generally, they cannot think because they don't have a nervous system, but there are some behaviors that can be considered this very simple forms of learning, even though it's not really learning. Yeah. Ultimately, all these things can be reduced to biochemical responses. Yeah. So that is, yeah. So they travel to the strongest oxygen source. It's saying, yeah, that's the, yeah, it's a natural reaction. This is a very interesting question, a philosophical question, which also my students quite often ask me, to what extent can they actually think? Are they somehow intelligent? And the example that I'm always using a little bit is if I have an object, you know, and I'll drop the object, then it falls to the ground, and then it's almost like saying, wow, how does the object know, under quotation marks, know in which direction it has to fall? Isn't it some form of an intelligence or so? No, it's not, obviously not, because it simply responds to the forces of nature, right? And you could actually see it's in a similar way with those microorganisms, that they're simply responding to chemical signals, right? But there is no form of consciousness. So it is indeed, to a certain extent, a philosophical question, but it's also not, it also has to do something a little bit on the words that we use, like, for example, thinking and having a consciousness. These are all very human terms, right? It's the question is whether these words actually can easily be applied to non-human living things, you know. So indeed, that's a complicated and a very interesting question, I have to say. Yeah. So I'm just going to go through some of these things here. The great topic. Thank you. If you're lazy like me or don't have access to a 3D printer, there is lots of sets and filters available on eBay. Yes. What you can try as well, I've also tried that, if you have a color printer, you can try to print those things also on overhead foil, or you can use a marker to color something, or you can use nail polish to also add color, right? So I'm just saying, so there are different ways of how you can do that. Yeah. Thickness, because plastic does allow some light to get through, you mean? Yeah, exactly. The plastic that I've got here, the thicker that you make it, the darker it becomes. And for this reason, I used, for those 3D printed filters, the thickness as a way to adjust the color. Okay, that's basically my way of adjusting the darkness, so to say. What's the difference between radiolarians and diatoms? Well, these are just different organisms, so to say. They're all both single-celled, both live in water. Okay, both have shells of silica, but they're different organisms. Yeah. With Christian, yes, I need to do a little bit of reading what it is. Okay, I heard of it of course already before, but I need to know how I can modify the how do you say the microscope to do that. I wonder why you use the Swift 380T specifically for the live stream today. Usually you use your Olympus. That's a good one. Okay, yes. This is correct. As a matter of fact, I actually had to. The reason is the following: my Olympus microscope basically does not allow me easily to exchange those filters. Okay. I don't know if I can actually do that. You know what I'm going to do is I'm just going to switch off this microscope here. Yeah, and I can actually show you. I have to. No, I can't. Can I do this? Let me see. I'm gonna show you. I'm taking apart my Olympus now. Okay. Okay. Let me see if I can get this out here. Okay. It's a little bit dusty, so maybe it's a good idea to get it out. Yeah. So this is the Wow, this is of my Olympus microscope, this is the condenser, right? Actually, it's the first time actually showing this to you, right? Yeah, this is how it looks like. Yeah, this is how the condenser looks like. Yeah, I lowered the stage first, otherwise you can't get it out, right? So this is how it looks like. Those knobs are for centering it. There is a lever that you can flip over here, and you can swing out this here, so that essentially for the 4 times. And what I have to do is, for the different DIC settings, I have to rotate this here. And setting number 3, that is for phase contrast. Okay, and then for the different objectives, I have to have a different setting, right? And the different prisms and everything is already in here, and it's not accessible. I'd have to take it apart, right? And for this reason, I cannot insert any filters. And that's essentially that's the only reason why I'm using now the other microscope. Yeah. So that's it. Yeah. So you see, it has only purely practical considerations. And by the way, in case you're kind of wondering here, yeah, this here is a Wollaston. It's also an optical system that it can swing out. It's all for DIC. Yeah. Yeah. So that's So I'm just going to put this back simply so that you understand why I've changed microscopes today. In other words, probably not a bad idea anyway. The reason being because most people actually, or many people, not most, many people actually have a microscope with a swing out filter holder, right? And so I cannot even do, honestly, I cannot even do those things that I want to do, that I showed you today with the other microscope, with the Olympus. Yeah, So let me have another look here. What if you don't have a sliding filter holder? If you don't have a sliding or swing out filter holder, like if you only have this push on filter, what you have to do then is the following. You have to cut out a cardboard circle, okay? And then what you do is you cut off an edge of the cardboard circle. So you know what? Do I have scissors here? I'm just going to demonstrate this to you. I'm just going to use, you know what I'm going to do? I'm just going to use, I'm just going to cut a piece of paper here. Yeah? You just do the following. This is just for demonstration, okay? So that you understand what I mean. Yeah? If you have something like this, then you try to make something out of cardboard that you fit in here, right? And then you have to do something like this. Yeah, and maybe a little bit more. Yeah, something like this, right? So you're blocking out the main light, and you only allow the light from the side to come in. And then you have to really experiment. And there are online, if you do some research, there's so many different variations of this, right? Essentially, how big it should be and the shape. However, there is one recommendation that I have. If you try something like, and by the way, if you want to, you can try the same thing also with a swing out filter holder. It doesn't matter, okay? But there was one interesting thing that I once read is what they recommended is because otherwise you only have light coming from the side. And you also want to have a little bit of general light. So they recommend that you also make a tiny hole in here, yeah, to allow a little bit of light to also directly hit the specimen. So most of the light is coming from the side, but a little bit also straight through, which doesn't make so that the background is a little bit grayish in color. Yeah? So many things to experiment with, right? So it's all trial and error. Yeah, but that's essentially the short answer. If you do not have a swing out filter holder, yeah, there has been any application on research has there been any applications or research on radiolarians? Yeah, of course. Yeah, I mean, people, of course, they researched them. Yeah, I'm quite sure about that. Honestly, there has not been pretty much any area in biology that has not been researched, and especially because the radiolarians look very pretty. Yeah, I'm quite sure that there are folks out there who are actually doing serious DNA studies on them. I'm not aware of any, right? But knowing from what I know about biologists, I mean, there's nothing that they have not studied. Yeah, so yeah. I'm pretty sure. I mean, just an interesting thing that I just remember. We just talked about foraminifera, which are basically found in sand. I know someone who, for his PhD thesis, actually analyzed the type of forams that are found in desert sand in a certain area, with the reason being that's a very interesting one, because they influence the sand consistency, and this has somehow an impact on construction on sand. That's something interesting, right? So those are those microscopic. Oh, thank you so much for the donation again. Thank you, Micropolo. So essentially, this means that there are apparently serious, under quotation marks, applications as well, because those shells of microorganisms somehow impact how much you can compact the sand and sand consistency, and apparently this has some impact on building stability on the sand. I was told. Now you know as much as I know about the topic, right? So this is just an interesting thing, yeah, because about an application. Do you ever look at we just talked about this. Yeah, I just recently got an antique form slide that seems to be mounted in oil under a sealed cover glass. In oil. Makes it a little annoying to view in some areas. Pretty nice specimen though. That's an interesting one. It's a so-called a permanent wet mount. This sounds a little bit like a contradiction, but I know that people also in glycerin, they have tried to make permanent glycerin slides as well. Yeah, talked about remounting old histo slides last week by using heat to melt the medium. Gave it a short at 170 degrees. Oh wow, it bubbles. Yeah, there are some solvents must have bubbled out. 170 degrees is quite hot. Generally, if it is glycerin gelatin, if this was used as a mounting medium, glycerin gelatin, then actually should melt at around 40 to 50 degrees already, and you should not overheat it. But if it melted at 170, then it must have been some kind of a synthetic medium, I guess. Yeah, or some solvent, some other resin-based medium. Yeah. What would you usually stain the cells with to make them visible? This was about the cheek cells. What I have tried as well is do the following. Take some fountain pen ink, just a regular fountain pen, and dilute it a little bit with water. Otherwise, it's going to be too blue. And try to stain your cheek cells. The cheek cells will actually absorb the fountain pen ink, yeah, and will stain blue. Actually works quite nicely, yeah. My Swift fails to produce such oblique light performance. I'm wondering why. Check. There's no reason why it shouldn't work, but check the vertical position of the condenser. Okay. I don't know about this. Okay. I mentioned this already, so I need to go up here a little bit. I remember how you taught us to put a little piece of carbon. Yes, I've also mentioned this or read this already. I'm trying to get back into microscopy so I can post again. Okay. I was having problems using Oblique and Reinberg. I have a Motic, and it has a sliding filter. I think I know this microscope. We might have actually one of them also in the schoolwear work. I'm going to have a look at this, but it should not be a problem. A sliding filter should not be a problem. Yeah. How thin are the center stop of the 3D printed filters? The central one, the thinnest one, is 0.2 millimeters. But it depends. I had problems getting it off this 3D printer because it was so thin. It rips and tears easily. Yeah, but I went down all the way to the thinnest one, which was 0.2 millimeters. This is where I cut out the thing here. On the other slide, the issue I came across with my sliding filter for Oblique is it seems to really smear the image. I lose a lot of sharpness. Interesting. There is every time, let's put it this way, every time when you have some kind of an object inside the light path, what happens is that you're actually bending the light rays. Yeah, you're diffracting them, and this always reduces image quality, especially folks who are into astronomy. It's also an issue. That's why if there are folks in amateur astronomy, they are spending quite a bit of time sometimes to design the holder of the secondary mirror, because this also blocks the light, and there's some light problems. Yeah, so the smearing of the image is indeed something that can sometimes be seen. Yeah. But I think it has nothing to do because you're sliding it. Yeah, there must be also, I labeled mine by printing a notch sign in the frame ring. Each notch is 1 millimeter, so even smaller diameters. That is so small to put a label. I can still tell what size it is. That's an interesting. You put a notch. My printing notches in the framing ring. Oh, I see. So basically, that's an interesting one. If you want to know what the diameter is, instead of printing it, if I understand you correctly, instead of actually printing it on here, you made notches on the side here to be able to distinguish the different filters. Yeah. Yeah, reasonably not much more than 400 times total magnification, because the higher you magnify, the more light you lose. Anyway, and the higher you magnify, the larger the central patch stop has to be. So you're losing already more light because of the larger diameter here, and also because you're magnifying much more. Yeah, I have an oil dark field condenser. That's nice if you have a specific one. Yeah, but it works with 100 times objective, but the working distance of the objective is so small it's hard to use. If you have special dark field condensers, especially from brands, what they have is they will have a so-called a concave mirror inside, which redirects the light. Yeah, so it's not just something that blocks out the light, but they will actually redirect the light by having rounded mirrors in it. Yeah, so this actually gives it also much more brightness. Yeah. How's your big jar of mixed samples? It's over there. I'm gonna show you, and it's I don't know. It looks messy. Yeah, as I mentioned, viruses. Do viruses have different shapes that can be confirmed? No, they can. That goes back to the question to the dark field. Even if the viruses have different shapes, you just see a blob because the virus is below the resolution limit. So you don't get any information out of it. Actually, you don't even know if it's a virus. So, but it's this was simply mentioned to indicate, as an example, that with dark field, you can actually theoretically see structures that are below the resolution limit, but you're just going to see a blob that's much larger, right? So that's, you don't you don't gain anything. Yeah, so that's a little bit the interesting thing here. So that is the thing here. This is how it looks like. This I think 2 weeks ago or so, we poured everything together, and this is how it looks like. Yeah. So what I'm gonna do now is there were so many comments and questions, so I'm going to quickly go through them to see if there's anything that's relevant for me. Okay. The question is. I would still like to see your microscope. Teeny Coco is saying, I wonder which microscope you mean. If you meant the Olympus one or the other one, I'm going to show you the one that I've been using. I'm a software engineer. Is there a software you wish existed in the realm of microscopy? Wow, that's a cool one. A software I wish would exist. Look, there is, I would say, if you just want, yes, there is something that I would like, that wish I would exist. And that goes, yes, and I'm going to explain it to you, and I'm going to explain it to everyone, because I was kind of hoping for this. Look. This goes into the direction of so-called virtual microscopy, especially at universities and also in hospitals. What you sometimes do is the following, is you digitize the slides. So basically when the doctor takes a sample from your body, somewhere, biopsy, and puts it on a microscope slide, sometimes it's digitized, and sometimes also for educational purposes, what you get is you get a very large image file, and then you can zoom in into the file, and then you can basically do microscopy on the computer. So it's very useful for education. Okay, so what you do is you basically stitch images together and you get a gigantic picture, right? And you basically then you just zoom in and you can basically explore around and you can add labels and so on. All of this stuff already exists. However, and that's something that I have not seen yet, is it would be nice if you do not only have a two-dimensional, but also a three-dimensional one. That means it allows you to also virtually focus. Okay, this would be a huge amount of data that you would need because you actually have different levels as well. But it would kind of give people really more of this microscopy experience, not just looking at an image, because otherwise it's just like looking at the picture and zooming in, but actually it's a level of interactivity where you can also, maybe by changing a lever, actually zoom through the different, not zoom, focus through the different layers. This would actually, would be kind of, would add a layer of interactivity as well. Why? Because when you are scanning a slide, and if, because it's automatically scanned, you need, of course, autofocus. Otherwise, if the specimen is not completely flat, there are gonna be some areas that are gonna be blurry. Right, so sometimes those scanning systems have some kind of a autofocus mechanism, but especially for slightly thicker specimens, you probably want to focus around a little bit and go look at what's more on the top or on the bottom. But this does not. I've not at least not seen any application yet that allows you to do that. Yeah, but I admit that this would probably be a huge image, data for a slide, because you don't only go two-dimensional but also three-dimensional. But that would be actually quite nice to have. So it's not just stitching in a two-dimensional way, but also in a three-dimensional way. Yeah, it's not stacking. Okay, if you're stacking, you're combining the focus, but that's not what I mean. Is I just want to have different levels. So, yeah. So from an educational perspective. I don't know. In schools, maybe. I mean, I think students still should work with a microscope and not just do everything on a computer, right? But still, if you maybe there's certain applications where this is actually useful. This would be actually something that would be quite nice. Another thing that makes me a little bit annoyed sometimes is about software would be the fact that those microscope cameras, those USB microscope cameras, I've not managed yet to connect them to a mobile phone. So basically they require their own drivers, and then you can connect them over USB to a computer. But I would like to actually connect them directly to a mobile phone. So that's actually a driver issue. And there are some cameras around there that allow you to go over Wi-Fi. But I would like to actually connect a USB camera directly to a mobile phone as well. So these were just two things. Otherwise, there are a lot of things already do exist. I mean, like measurement software and so on. Yeah. So this is, so that's the thing here. An accessible, affordable automatic slide scanner would be also nice to have. Yep, they do exist already. Yeah. But you can actually also, if you want to stitch your own slides together, it's also possible. It just takes a lot of time. Yeah. So these are motorized systems that, yeah. So I'm just reading. Oliver Wood, off-axis dipole illumination like used in lithography, minimize the XY distortion when Z-stacking. I don't know. That's yeah. Minimize the XY distortion when Z-stacking. Don't know about that. That's an interesting one. Okay, because when you're stacking together, you're also introducing artifacts. Yeah. So, but 3D. Let's. I'm reading. Software-wise, it's simple. You're just taking scans in every level of focus instead of just one, and then overlaying them. Yep. The layers. Yeah. So that's basically. Yeah. So from programming, it's very simple. Apparently. Yep. But that would be actually a nice thing, because I know that there are quite a few programs already out there that allow you to actually do some kind of virtual zooming. It's like Google Maps for microscope, so to say. You can actually navigate around and zoom in. Very nice. And in order to make this very smooth, the picture is actually, the high resolution images actually also split down into lower resolution images, which actually load faster. So you get a very smooth experience. But of course, adding some kind of a focusing layer to it would be kind of interesting as well. Yeah. Need to bail out now. Another great presentation. And honestly, people, I'm also going to bail out now, because I've been already talking 1.5 hours. Actually, yeah. Today I did not look at this sample here. I don't know if it's going to be very interesting or not. It's kind of cloudy, so this means there are some algae growing over here. But I'm going to call it a day today. I'm going to call it quits. Have a look at my other channel called All Things Microbes, which I try to revive a little bit now. If you want to have a little bit more of in-depth biology videos, yeah. I think I'm just going to call it a day today. I hope that you liked the video. I'm always very happy for recommendations of what to look at and what to talk about. I would like to thank all of you for your contributions. I would like to also thank you for your donations. I'm going to, I won't forget to check my emails. Okay. And I'm going to say bye-bye, and still have a nice weekend, and hope to see you again next week. All the best and happy microbe hunting to all of you. Bye-bye.